Welcome back to my YouTube channel Infinite Knowledge, and we are back with another great project, and that is EV charging system. So you can see we are charging our EV, we are charging our electrical vehicle through the solar system. You can see this is a solar system, and I have considered the solar system which has nearly 213 watt, not a volt, 213 watt. Voltage is 30 voltage, and the current is nearly 6 to 7 ampere, and we have used the boost converter to boost the voltage to the satisfactory level because our battery is 48 volt. So why we have considered the 48 volt? Because mostly if you consider the electrical vehicle two wheeler specifically, then the battery may be a 48 volt or maybe a 60 volt in between. So that's why we have considered respectively it, and we have only considered the one solar panel, only series, in the series also, in the parallel also, only one panel is there, and that's why we are getting 30 volt and 6 ampere. So as I start the simulation, it takes some time to generate a satisfactory voltage, and then you can see your battery is getting charged. Here I have used one breaker, and once the satisfactory voltage come after a 0.03 second, this breaker is on, and then your battery getting charged. So you can see right now 0 ampere is there, but once it's crossed the 0.03, your battery is getting charged. Negative ampere clearly means that your battery is getting charged. Positive ampere, it clearly means that your battery is getting discharged. Initial charge of battery is 80 percentage, so initially it was 80, right now it is 80.01. So if you want, you can check the waveform of the battery also. So you can see it is getting charged at 0.03 second, your breaker is closed and battery start charging, and that's why the curve is upward. And the second one is ampere, which was a negative ampere, you can see. And the voltage, this is the voltage of your battery, which is nearly 51 or some 51, 51, 59. So yes, this is how your system is working. You can change the slider. So input is changed. If in the input is changed, output is changed, voltage and current will get changed. And yes, you can see this is the voltage of your solar panel, and this is the current of your solar panel, 30 and 6. And here I have used the MPPT, which is P and O type. What is the MPPT? If you basically know the MPPT, very basic concept of the MPPT is maximum power point tracking. And what it clearly means, then what if you provide a 40 watt as an input, your output must be a 40 watt. So how it can be possible? So let's say if your solar is 10 volt, if your solar is generating 10 volt and you have a load, you have a battery which has only a 5 volt, and 5 volt battery you need to charge. Okay, so at that condition, what you have to do, you have to use a buck converter which convert the voltage from 10 volt to 5 volt and increase the current. So let's say it is a 40 volt system, so 10 volt into 4 ampere, so it will be a 40 watt. Similarly, if your output must be a 5 volt and the 8 ampere. So this conversion, if you multiply this, you will get a 40. If you multiply this, you will also get a 40. So this how can be this possible? It can be possible due to the MPPT. We have used MPPT, and MPPT control the buck converter, and buck converter control this input to this output. So you can see our power rating is same, but we have changed the voltage, and according to we have changed the current, and this is the purpose of MPPT, and that's what we are doing here. And you can see we are getting very satisfactory output which charge our battery. So this is a very basic, very simulation. If you want this simulation, I can share you. You can connect with me through my email ID or through my WhatsApp number that is given in the description box. For any type of MATLAB project, you can connect with me through my WhatsApp number. And if you want any modification in specifically this project, I can help you, and I will provide the simulation also. So thank you very much for watching this video. If you have still any query, just comment it. I will definitely reply. Thank you very much.